Hello viewers, welcome to this next lecture on the MOOC course on mathematical portfolio theory. In this lecture, we will now start a new component of the course, namely the non-mean variance portfolio theory, which is going to address some of the issues that are unaddressed as far as the Markowitz framework is concerned, along with some of the shortcomings. Now, in this broader framework of what I am calling as the non-mean variance portfolio theory, I am also going to include and begin with what is known as the utility theory and utility functions. So, what is the utility theory all about? Utility theory is an important concept in economics which quantifies the amount of pleasure or utility that one derives from one's wealth level. And for this purpose, what we will do is that we will look at the axioms of the utility functions and look at the non-mean variance framework, essentially driven by the goal of maximizing the expected utility of investors, and subsequently this will be used when you talk about multi-step portfolio allocation, namely dynamic programming, as well as when you talk about the Hamilton-Jacobi-Bellman equation. So, accordingly, we begin this lecture. As I said, that this topic is going to be on non-mean variance portfolio theory. So, the first topic that we look at is what is known as the utility theory and consequent analysis. So, utility measures or is an indicator of the relative magnitude of satisfaction that someone derives from something and is a subjective or qualitative index of preference. Now, this is a very general statement. So, on a more localized level, we say that in the context of our discussion on portfolio theory, utility theory is made use of for the purpose of investment decisions, and we will discuss extensively on how this is done. So, in case of certainty, the utility theory says that a person should assign a numerical value to each alternative. So, in this case it is going to be each alternative portfolios, and then choose the alternative with the maximum numerical value. So, what the utility theory says is that we will use utility theory in order to tag or assign a number for all the alternatives that are available to us. So, in this case, in the context of portfolio theory, we will essentially look at different alternative portfolios that are available for investment, and to each of them we will use the utility theory to assign a number which is a qualitative indicator of the amount of satisfaction that we can derive by holding on to that portfolio, and accordingly it also enables us to identify which one of them is preferred over the other in terms of investment and from the perspective of our utility as an individual investor. And note that this utility is a concept that is subjective and can vary from investor to investor depending on their individual preference for risk, and this is another topic that we will start off towards the end of this lecture. Okay. So, now we begin with the basic utility axioms. So, this is going to be a fairly elaborate discussion. So, I say that as a prelude or as a preliminary discussion, the utility analysis, we enumerate below the assumptions or axioms. Right. So, the first assumption is the following, that people have preferences. So, by this I mean that given a choice between two alternatives, say A and B, this could be investment alternatives, we say that the person prefers the alternative A to B is indifferent between A and B and prefers B to A if respectively we have UA greater than UB or UA is equal to UB or UA is less than UB. So, this means that between two alternatives A and B, for each of those alternatives I am going to assign a numerical value, that is U of A and U of B respectively. Then in case U of A is greater than U of B, there we say that the person prefers alternative A to B. If UA equal to UB, then we say that the person is indifferent between the alternatives A and B, and finally if UA is less than UB, then we say that the person prefers B as compared to A. So, how exactly is this UA and UB determined is something we will discuss as we move along this topic. So, the second axiom that you have here is that people's choice are transitive. So, if a person prefers A to B and prefers B to C, then we say that the person prefers A to C. So, this means that if we have three alternatives available A, B and C, and if an individual prefers A over B and also B over C, then this implies that the person prefers A over C. So, this is consistent with our typical definition of what is transitivity. Third point, objects with identical utility and identical in terms of, so this should be R, identical in terms of desirability. So, this means that if alternatives have identical utility, then it implies that they are identical in terms of desirability or preference from the point of view of the person concerned. So, this means that if u a is equal to u d and u a is greater than u b, then since u a equal to u d, I can say that u d is greater than u b. Fourth axiom, utility has applicability, that means it can be used in case of risky decisions if u a greater than u b and u b greater than u c, then there exists a risky decision involving A and C that satisfies the following, that is 1 minus probability of C, P o, which is denoted by P of C, into U A plus P of C into U C is equal to U B, where probability of C is P of C is the notation for probability of C, and consequently P of A, which is 1 minus P of C, is the probability of A. So, this means that suppose that we have three alternatives A, B and C, and the utility of A is greater than utility of B and utility of B is greater than utility of C. So, that means the utility of B is sandwiched between A and C. Then you can create a risky decision involving A and C such that a linear combination in terms of probability of A utilities of A and C will be equal to the utility of B. So, this means that so here I take utility of A and utility of C, I multiply the utility of C with probability of C and I multiplied the utility of A with probability of A, which is 1 minus probability of C, and this is going to be equal to utility of B. So, this is something like we look at an investment and we find that amongst the three investments, I can actually the utility of the investment B here is equivalent essentially to the expected utility. Remember that this is the utility into the probability and this is the utility of A with the probability of A. So, this is the expected utility of A and C. So, the utility of B can be written as a combination or as the expectation of the expected utility of A and C. The fifth axiom is that the ranking of alternatives remains unchanged even if some irrelevant additional object is added to the ranking. So, that is if u of A is greater than u of B, then u of A plus u of E is greater than u of B plus u of E, of course, provided that E is something that affects neither A or B. Okay, and now we come to the sixth axiom, and this is a really important axiom. So, this says that the risky decisions of investments are driven by the objective of maximizing the expected utility. So, just to elaborate on this, so that is, if there are n possible outcomes denoted by, so this could be alternative investments, so which you denote by O1, O2 all the way to On, then the investors expected utility is what? It is going to be given by E of u, the expected utility. It is going to be given by the utility of the ith outcome multiplied by the probability of pi oi of the ith outcome, and I sum this over all possible outcomes, namely I equal to 1 to n, where u is a positive function that assigns utils, that is numerical values. So, remember, so far I have been talking about the numerical values being assigned. So, these numerical values are something which we will call as the utils, and this assigns utils u of oi to outcome oi with respective probability of pi of oi, which is the probability of oi occurring. Okay, so the next thing that we come to is the utility of wealth. So, we will now start getting a little more specific in terms of precisely stating what this function u could be, what are its characteristics, and how we can make use of them, and finally, we will also look at how we can actually calculate the expected utility in the paradigm of an investment or among several alternative investment. So, accordingly, we start off with the topic of utility of wealth and consequently of course of returns. So, a utility of wealth function is a formula or a graph which represents the extent of utility or satisfaction derived by a person dependent. So, that means this wealth function is dependent on the different levels of wealth. So, graphically a typical utility function in case of risk averse investor will have the wealth on the x axis and the corresponding utility uw on the y axis, and it is basically going to look something like this. Since investments in real world involve risk, so the consequence of this is that the analysis of risky investment alternatives involves being equipped with the probability distribution of returns. And this is for each of the investments. So, this is an observation that we have already encountered and is slightly different from earlier, and that is that in case of real world investment, and by this I primarily refer to risky investment, the analysis of all these risky investments even in the framework of utility theory requires you to have the information about the probability distribution. Remember that when you are always looking at the randomness in any structure in terms of investment, obviously you will need to have the corresponding underlying probability distribution. So, in order to even analyze this in case of utility theory, you also need to have to be equipped with the probability distribution of what? Of the returns, because eventually what you are going to look at is we are going to look at the maximization of the expected utility of returns. And this information about the probability distribution of returns this has to be made available in case of all the investment alternatives that are actually being considered to be determined for the best investment in the utility theory framework. So, therefore, a utility function, so each of the investments alternatives and a utility function that assigns to each of these alternatives a numerical value or utils. Okay, so this means that you first have to be equipped with the probability distribution of returns, and for each of this alternative investment and also you have to have a utility function that assigns a util to each of them. So, just to sort of sum this up, it means that when you are doing the analysis, you need to be essentially equipped with two things. The first is of course the probability distribution of the returns, and consequently once you have that, you need to also have a utility function on the basis of which you are going to assign utils or the numerical value to each of those alternative investment. Okay, so now as noted in the as I have already mentioned here, that eventually what is our goal is to maximize the expected utility. So, drawing motivation from that, so we say that as already noted, the basis for this analysis involving the utils is the maximization of the expected utility. Now, it may be noted that unlike deterministic outcomes such as bonds, where one maximizes the utility, in case of risky outcomes such as investments in a portfolio of stocks, we need to maximize not the utility, because the return is a random variable. So, we need to maximize the expected utility. Alright, so now let us look at a couple of examples to have better clarity on this topic of expected utility and its consequent maximization. So, first we look at a couple of examples involving the utility and since it is a random return and it's a risky, it's a random return resulting from a risky investment. So, we will have to talk about not just the utility, but also the expected utility. So, first one I will look at a very simple generic example, and the next second one is going to be a specific example involving multiple assets and multiple investors, for each of those investors we assign a different utility function depending on their risk preference. So, first we look at this example 1. So, here suppose that we enter into a coin tossing driven risky investment. Now, if the utility function is u, then the expected utility of the risky investment is given by E of u, and this is going to be dependent on the coin toss. And this is going to be equal to probability of a head multiplied by the utility when a head comes plus probability of a tail into utility of a tail. Let us look at example 2, which is going to be a little more elaborate example with more numbers that show up, so that you can actually start looking at the concept of utils in practice. So, this example 2, so what we do is that we consider the following probability distribution of returns of 3 assets, and I will identify these assets as A1, A2 and A3. So, now we tabulate the probability distribution So, we consider 5 different possible values of returns, namely minus 3%, 0%, 3%, 6% and 9%. So, for asset A1, we see that we assign a probability of 0.5 to the return of 3%, probability of 0 to 0%, probability of 0 to 3%, probability of 0 to 6% and the probability of 0.5 to 9%. So, this means that the returns can be minus 3% with probability 0.5 or 9% with probability 0.5. So, this is like a binomial model. For asset A2, we have minus 3% has the probability of 0, then 0% return comes with a probability of 0.5, 3% return comes with a probability of 0, 6% return comes with a probability of 0.5 and 9% return comes with a probability of 0. And finally, for asset 2, 0% returns has a probability of half and 6% return comes with a probability of half. And in case of a third asset, which is a bond, 3% return comes at the probability of 3% with a probability of 1, and the remaining returns all have a probability of 0. So, you see that, so from here you can see that the expected return for the first asset is going to be minus 3% into 0.5 plus 9% into 0.5. So, this is 3.0%. For the second asset, it is 0% with probability 0.5 and 6% with probability 0.5. So, again the expected return is 3%, and in the third case it is a certain return of 3% with probability 1. However, even though they have identical expected returns, they have different risk as given by the standard deviation. So, this turns out to be 6.0% in case of the first asset, 3.0% in case of the second asset, and since the third asset is a bond, so obviously the risk associated with this is going to be 0%. So, this means that, so here I have identical expected return. Okay, so now what you do is we look at, so we assume that there are 3 investors with the respective utility functions being, so we will give the utility function as UA of R is equal to 100 R minus 50 R square, and this investor, as we will see later, qualifies as what is known as a risk averse investor. Utility of the investor B is 100 R, and this investor is risk neutral, and as I said later we will see why this is risk neutral, and UC of R is equal to 100 R plus 50 R square. This is a risk seeking investor. So, the corresponding graph for each of them against R. So, I will have R on the x axis. The first one I have a utility of A, the second one I will have utility of B, and the third one I will have the utility of C. So, in this case the respective graph look like this. Okay, so what we do now is we let the returns for the 3 investors or for the 3 assets B, R1, R2 and R3. Okay, now let us look at case by case of the expected utility of each of those investor. So, first of all we will talk about investor A. So, the expected utility of investor A in case of the return of the first asset, what is this going to be? This is going to be, remember that UA of R was 100 R minus 50 R square. Now, R takes the value of minus 3% and 9%. So, remember that this took minus 3% and 9% with probability half. So, accordingly the utility in each of those cases is going to be 100 into minus 0.03 minus 50 into minus 0.03 square, and in case of 9% the utility is going to be 100 into 0.09 minus 50 into 0.09 square, and each of these utilities happen with a probability of 0.5. So, the expected utility is going to be 0.5 multiplied by the utility at 3% and 0.5 multiplied by the utility at 9%, and we add them up. So, this becomes equal to 2.785. Okay. Now, in case of the second asset, what are the returns? So, in case of the second asset, it is 0% or 6% with probability 0.5 each. So, then the utility values are going to be 100 into 0 minus 50 into 0 square for this case, and 100 into 0.06 minus 50 into 0.06 square, which is this case, and each of those utils have a probability of 0.5, and so the expectation is given by the sum of this, and this turns out to be equal to 2.91. Similarly, the expected utility of R3, this is going to be again, so remember that in case of R3 it was only we had 3% with probability 1. So, that means that it is going to be 100 into 0.03 minus 50 into 0.03 square is the utility value, and of course, this is multiplied by probability of 1, and this turns out to be equal to 2.955. Alright, so you can actually carry out a similar exercise for investor B and C. So, in this case what you have to do is that you just it's the same exercise as investor A, except that you just change the utility function. So, for investor B, it turns out that the expected utility in case of R1, this turns out to be equal to 3. The expected utility in case of R2, this is also 3, and expected utility in case of R3 is also equal to 3. Now, let us just come to the last investor, investor C. So, in case of investor C, we have expected utility for first asset, this turns out to be 3.225. Expected utility in case of second asset, this turns out to be 3.09, and expected utility in case of the third asset, this turns out to be equal to 3.045. Okay, so now that we have the numbers in place, we are now in a position to make an interpretation of this. So, for A, you see most satisfaction comes from asset A3. So, if you observe carefully here, asset 1 utility, expected utility, asset 2's expected utility, and asset 3's expected utility, you see that the highest is in case of the third asset. So, for the investor A, most satisfaction will come from A3. Now, you see in case of investor B, all the expected utilities are identical, namely equal to 3. So, this means that for B, the investor is indifferent to each of the 3 asset, and for C, you see that the highest value, so it is 3.225, 3.09 and 3.045. So, in case of investor C, the highest value is 3.225 of the expected utility. So, the most satisfaction comes from A1. So, in summary, so now remember that investment A1 had the highest risk, A2 had the second highest, and A3 had the least highest or the least value. So, investor A prefers A1 rather A3, which has least risk, and this is consistent with our earlier statement that investor A is risk averse. Investor B is indifferent to A1, A2, A3. So, again this is consistent to the utility function for risk neutral, and investor C prefers A1, which has largest risk, and this again is consistent with that investor C is risk loving. So, this is risk averse, risk neutral and risk loving. So, we come to the last topic, or rather just the introduction to the next topic that we are going to do, and that is going to be on risk attitude, and we will discuss this in the next class. By in terms of risk attitude, what we mean is that there are different investors have different level of risk preferences. So, as we have seen in the example, some of this some investors, they can be risk averse, some of them can be risk loving and some of them can be risk neutral. So, what we are going to do is subsequently this concept of risk attitude, we will see this in the paradigm of utility functions, and we will look at the case of risk aversion, risk loving and risk neutral. So, just to sum up what we have discussed today, we introduced the concept of utility functions, and which is a quantitative representation of the satisfaction that one derives from any investment strategy, that is in the context of our discussion. And we talked about the fact that utility functions are used to assign a numerical value or utils among the different investment alternatives, which in turn helps us to identify our preferences. And we recognize the fact that we need to only calculate what is the utility in case of the returns of any investment being completely deterministic. However, in case we get into risky investment, then the corresponding utils is going to be a random variable, and so we need to calculate the expectation of that. So, irrespective of whether you are looking at just the utility for the deterministic case or the expected utility in case of the random case, we need to, the eventual goal from the point of view of the investor is to maximize the utility or the expected utility in the respective cases. And we defined what is going to be the expected utility, and then we looked at two examples, one which was a simple example involving a binomial structure, and then we looked at a well tailored example of 3 assets and 3 investors. The 3 assets were designed in such a way that each of them had their expected utilities to be identical, but they had different levels of risk, and we choose the utility functions for the different investors to reflect their nature or their preferences of being risk averse, risk neutral and risk loving. And why these utility functions qualify as risk averse, risk neutral and risk loving respectively is something that we will look at when we discuss the next topic of risk attitude, and namely characteristics of utility functions for investors who are risk averse, who are risk loving and who are risk neutral respectively. So, this brings us to the end of this lecture. Thank you for watching.